This is the second in a series of 3 videos on integration by substitution. If you're looking for a simpler case, the first one was looking at linear substitutions, is a nice, slightly more gentle intro to this. This one's looking at a case where the substitution we've got to make is a little bit nastier. The third video in the sequence is going to be one we have to start being very inventive and using trig substitutions in surprising ways. So in this one, the integral 3x times by x squared minus 1 all over root of x squared plus 9. There's a lot of complicated things going on here. There's no other nice way, as far as I'm aware at least, of doing this integral. We want to find the substitution. Choosing what the most complicated part of this may no longer be obvious, but that numerator at least looks somewhat nice, even though it's a bit of a pain. That denominator is the scary thing, that root of x squared plus 9. It doesn't look like we're going to have a nice way of dealing with that. So for the substitution, I want to focus on that. Now, we could be tempted to make the substitution u equals root x squared plus 9, but I think it's going to go more nicely for us if we just let u equal x squared plus 9, because if we get root u, that's fine, we can still work with that, and it'll make getting du by dx a little bit easier than if we had the square root involved as well. So if we make this our substitution, so often there's 3 steps to doing the substitution. We change the limit, we change what's inside the integral to in terms of u, and we get dx in terms of du. We have no limits this time, so we don't have to worry about this. But we want to change what's the integrand, the whole thing inside the integral, to be in terms of u, and we want to change dx to be in terms of du. Now, when you're making the harder substitution, I'd actually recommend you only change the very easy things to change inside your integral, because some things might end up cancelling anyway. So for now, I'm going to keep the numerator, which looks fairly nasty in terms of x, and all I'm going to do is make the very obvious substitution. Now we've got x squared plus 9 is u, so we can rewrite that denominator as root u. You'll see why I'm leaving the numerator as it is for now. You might be able to predict which other bits we want to change, but I'll hold off on trying to make those predictions just yet. So getting dx in terms of du, well, we want to find either du by dx or dx by du in order to do that. If we differentiate both sides with respect to x, we'll get du by dx is equal to 2x. And again, if you've seen the last video, we can treat this as a fraction in this case. If du by dx is equal to 2x, multiply both sides by this dx, and we get du is equal to 2x dx. And if we divide both sides by 2x, we get dx is 1 over 2x du. So we're going to replace dx there with 1 over 2x du. Hopefully you can see now why we benefited from not trying to get everything in terms of u straight away, because we've got a 3x on our numerator and we've got a 2x on our denominator. So we're going to have some x's are going to simplify here. I'm actually also going to recommend that we try and factorize something out. So we can, if we factorize the 3 over 2 out from so these two x's are going to disappear for us. So once we make those x's disappear, all we're going to be left with on the top, we're going to have x squared minus 1. On the bottom, we're going to have root u du. Now, we're still not ready to integrate just yet because we've got x involved in this integral. So we are going to have to deal with that bit. But holding off meant at least we got those x's on our numerator and our denominator simplifying before we had to worry about changing them all in terms of u. So from here, what can we do? Well, if x squared plus 9 is equal to u, then if we subtract 10 from both sides, we're going to get u subtract 10 is equal to x squared minus 1. So that numerator is just u subtract 10. So we've got u subtract 10 over u du. And now this is a more typical sort of integration we've got to deal with. Again, 2 ways you can deal with this. You can think about this as u subtract 10 times by u to the negative a half and expand your brackets. Or you can think about it as splitting up your fraction. So we can split up into u over root u. Now, u over u is u to the 1 divided by u to the half. So we just get u to the half when we do that. And then we've got subtract 10 over root u. well, 10 over u we can rewrite as 10u to the negative a half. And now this integral we should be backing ourselves with. So I'm going to go through this a little bit quicker now we're up to this stage. So we'll get u to the half integrates to 2/3 u to the 3 over 2. And then this subtract 10u to the negative half is going to integrate to subtract 20u to the half. You can put plus c inside these brackets if you want, but because it's just a constant, I'm going to choose to put it outside, and this will represent a different constant to if I put it inside the brackets, but it's absolutely fine just to put plus c on the outside there. And now I might as well tidy this up a bit by expanding those brackets times 3 over 2. So we're just going to get u to the 3 over 2 and then subtract 30 u to the half plus c. Are we done? Almost. One extra step needed. The integral was in terms of x, so we want to give our answer in terms of x. Well, fortunately, that's easy enough because we know u in terms of x. So at the end, all we need to do is go through and replace all our u's with x squared plus 9. So we've got x squared plus 9 to the 3 over 2, subtract 30, x squared plus 9 to the half, plus c, and we're done. Thank you very much.